Hello and welcome to this talk, Re-implementing IP Authentication. I was asked before the talk what IP stands for. Is it intellectual property or Internet Protocol? And it's unfortunately Internet Protocol. And there's not much for you to learn in this talk besides the fact that you should not implement IP authentication. It's a very, very bad idea. But I will later go into why we had to re-implement it in the first place. Short slide about me. I'm a senior engineering manager at Statista. Before that, I worked at Xing, also as an engineering manager. I'm a backend developer by heart, and my first job was as an admin, so knowing how the internet works was pretty important for everything that happened. So what are we going to talk about in this talk, or me? First of all, I want to tell you what exactly we were doing, because we had so many what the fuck moments, and I hope you will have lots of facepalm moments in this talk. And then we deployed, or we tried to deploy 3 times to production, and we rolled back. And then while we did that, we observed strange things, how the internet works. And in the end, I have a couple of takeaways. Maybe that's what you can get from this talk. But let's start with the background. So what are we doing at Statista? Like many organizations, we have an old PHP monolith that has been working great and has served us well while we grew. But it grew pretty uncontrollably. You know the story. And so what do? You want to break it up into microservices, of course. That's what you do. One of the first things that you then have to tackle is authentication. How does a user authenticate to both systems? You know, the old world, the PHP monolith, and the new world, the microservices that you're establishing. For that, we are using Auth0. They also have a booth here. Maybe some of them are also here. But let's make a little poll. So put your hands up. How many login methods does your platform support? And keep your hands up. 1. Okay, keep your hands up. Is it 5 that you have to take care of? I still see some hands. More than 10? I see 1 hand and my hand. Yeah. These are all the authentication methods that we have to support. There are some that you know, username, password, SAML, OpenID, Connect, and then it already gets weird in this list. OPAC, Shibboleth, OpenAthens, Easy Login, Partner Login, Bücherhallen, Stadtbibliothek Bremen, and Login by IP. That's what we're going to talk about. And the ones which are red are the ones that were invented at Statista for our customers. And you know that inventing login mechanisms is never a good idea. So what is login by IP? At first, and of course also why we offer it. We offer it because of course our most important clients, they demand it from us. And the way it works is that you have a network of a big client, and then you have a NAT router, and they have a fixed IP address that they are using to access us, and this fixed IP address is mapped to a single user that gets logged in. There are a couple things to unpack here. So everyone in this network arrives at Statista as one single user, so we cannot identify who it is actually, who's there. There's no real good way to customize things on the website, because you cannot distinguish between, is it user A, user B, they all look the same for us. And also, it's an implementation detail on our end. As soon as they arrive at our site, they are already logged in. So there's no user intent taken from their side to log in. They are already authenticated. Sounds great. So the good things are that it's very easy to set up. The customer just needs an IPv4 address, which is static on their end. They tell us this. They really don't have to care about user licenses, which is good for the customer, but sucks for us because we only see one user and we don't know how many there actually are. Especially customers that we have this authentication method are universities on large campuses. So as soon as you are logged in on the campus Wi-Fi or whatever, you can access Statista and you are logged in. Low user friction, it just works for everyone. The bad, now we come a little bit closer to what our pains are with that, is that, yeah, we don't know how many users are coming through that. There's limited flexibility on, shutting off individual user account or, like I said, customizing the site. And also, if something bad happens, we don't know really who it was. And the ugly proxies. I already mentioned no distinct login attempt. Then there is network address translation, and VPNs, which interfere with IP addresses. IPv6, I don't even know how the system behaves if someone wants to come through IPv6 to us. No idea. How was it implemented? Well, at the monolith, it's pretty simple. There's the first request from the client. There's a check IP function in PHP in this case that looks inside the database. Do I know this IP? What's the corresponding user? Okay, we log them in. Fine, we're done. But we are moving away from the monolith, like I said. And so we had to re-implement it and think about it. And it's going to get a little bit complex. So please familiarize yourself with the legend already there. What does each color mean? It's going to get a little bit complicated. The user first arrives at our CDN. Nice. Then they get sent to the monolith as the first route. There we have the function which checks the IP cookie. And we do have a cookie there, which is called SSO IP login. Inside there, we store the IP address of a customer after they have logged in once. And if this matches the IP address that the client is now connecting this, we already know they have already been authenticated. It's kind of like a way to cache a little bit of the stuff that comes now, because if we don't know the user yet, we go to a lambda, then we go to auth0, then we go to another lambda, which then looks in the user DB. Do I know this IP already? If we know it, we come back to remix SSO, we write the real SSO cookie, but we also update the IP address inside this cookie so that next time we don't have to traverse through all of this. And finally, we're going to send a redirect so that the user can then, do this again. We just check the content of the IP login cookie and we know, request and IP login cookie match, they are logged in. Fine. Were you able to follow this? Yeah. This was basically last year ago. From these 11 login methods, we were able to switch 10 successfully, 0 downtime. Wonderful. We were hiding login methods that we transitioned behind kind of poor man's feature switches, where if you had a certain cookie, you would go into the new method. Not very good. But also we tried the last method, IP login. We set up a fixed IPv4 tunnel and everything always worked. So we were very, very confident that rollout would be, again, very smooth. So production deployment number 1 happened. We did this in a kind of mob fashion because we know when we deal with a monolith, no one really knows everything, so the collective wisdom helps when things go wrong. So we just hop on these calls and then we deploy together. We started to deploy and then Statista.com was getting really slow, timing out, overall performance degradation, and a huge error spike. What did this error spike look like? In Datadog, it was pretty bad. So what is it? 105,000 errors within 5 minutes or something like that was really bad. So it was time to roll back for the first time. All right, then of course, we thought, what has happened? So we went into the analysis. And this is the AWS Lambda execution duration dashboard that we looked at. And we saw that we were hitting the 30 seconds max execution time and the Lambdas were simply killed that were handling all of this. Looking again at this chart, what could be the problem? This, a database lookup. Let's look at it. And so, yeah, we looked at it a little closer. So it's an IP address that the client sends over. And in the database, we have a table of CIDR ranges mapped to the customer ID. So, yeah, within microseconds, you have to determine, does this IP address match any of the CIDR ranges that we have in the database? How do you do that? You go to Stack Overflow, and this is how you efficiently calculate that inside an SQL statement. Very convenient. And if you look into our code, someone thought it's a really good idea to just copy exactly that line from Stack Overflow. Maybe our code was there first before the Stack Overflow. We don't know because we lost a lot of part of our Git history when it was migrated. But chances are it was the other way around, that we just copied from Stack Overflow. But hey, so if you ever need it, that's how you do it in SQL. But still, I mean, we quickly realized that this was a bottleneck. And so what do? You introduce a new system to it. We thought, let's do it with Redis. And so every, I don't know, 10 minutes or something like that, we synchronize not the CIDR ranges anymore, but we expand them to IP addresses. We expand the CIDR addresses into unique IP addresses, and then we put them into Redis IP address and customer for quick lookup. Problem solved, we thought. So this is now what our architecture looks like. It has just gotten a little bit more complicated, but that's fine. Then we started to wonder, what's actually, how many IPs are we talking about? Then we found out 72 million IP addresses are in that. I will come to that a little bit later, but it turns out that some of our customers were giving us really, really big CIDR ranges. A lot of our customers are from the US and universities, and they were, they've been on the internet for a long time. They have large IPv4 addresses that they can use, and they just give it to us. And the CRM for entering these IP address ranges, it took everything, so you can enter anything in there. Also, we are dealing with 120 requests per second, so that's the kind of thing that we have to, where we have to decide if we want to log in this user or not. Yeah, we should have done this before, but we didn't. But now we were all prepared. Deployment number 2 was around the corner only a couple of days later. Again, we hopped on a call, but we were already very anxious, so we saw huge error spike very quickly again. Not as large as the one before, but still significant, and also custom support was also not, they were also a little bit shaky because they knew we were attempting this for the second time. So they also quickly told us that customers were already complaining again. So we rolled back for the second time. Yeah, so this is actually what the customers saw. We never saw this because remember, for us with our tunnel, our IPv4 address, it always worked. But this is like what the customers saw on their end. Yeah, unexpected error. And I don't know if you can read it, but it says you may have pressed the back button, refresh during login, open too many login dialogues, or you disabled cookie usage since we couldn't find your session. That's a lot of pointers which are very, very unspecific. And yeah, we just call it the you may have pressed the back button error because we don't really know what's the source of it. Could be many. Oh yeah, there it is larger again. But then it was Christmas time last year, and so we all took a break. And we thought about, okay, how can we make this happen? So we came back and we said, let's do a pre-mortem. Let's think about what can go wrong. So we collected all these things and came up with we tried to come up with actionable plans of what we want to do if things fail again, if we deploy for the third time. Yeah, we had a response plan, and we said, we don't roll back this time, we fail forward. That was the mission. So, mid of January, again, we hop on the call and we deploy again. And huge error spike again. Great, but we said we don't roll back, we fail forward. And we looked into our pre-mortem, and this was true, things only fail at scale. And the return of you may have pressed the back button error, because that's what we were seeing. Our response plan said that we want to get into one-on-one contact with our customers because we never saw this error. We couldn't reproduce it. So we wanted to find this error. Yeah, this is again what the customers saw. Same picture as before. And we got into contact with our customer support and asked, please get us on a call with a screen sharing session with customers so we can observe what's going on. And we had interesting calls with colleagues or with customers where we said, now please open the inspector of your browser, go to the network tab, and then scroll up again a little bit, scroll down. Yeah, that's what we want to see. Yeah, it was an interesting experience. Yeah, then we also saw some other errors, and then all of a sudden this came up. So like all the UI styling was wrong, and we were like, oh, things are getting worse. And we were still, but we said we don't roll back. We fail forward. Turns out another team did a deployment while we were doing that was even more broken than ours. That's why we saw this. But of course, we first thought it was our fault. But it wasn't, at least not this. Oh yeah, so we deployed 26 times in 4 days. That doesn't seem much, but if you know that normally we would deploy the platform once a week on Monday, then this was pretty significant because also deployments, they took like 20 minutes. And we had, around about 8 customer calls and finally saw the error in the wild. This one, and we had a very competent lady that was showing us her screen and guiding us through all of this. So we figured out what happened. So it turns out we look at the IP address from the request at two different places. Here it's clear, but also we are looking at it here to write the cookie. Now, those things are in different AWS accounts. The monolith lives inside a very old AWS account that is configured totally different than from the other AWS accounts. So we came into this kind of redirect loop here because we were looking at two different IP addresses that we found. The check IP cookie function was looking inside the SSO IP login cookie, didn't find the same or the IP address of the request it was detecting, but in the Remix SSO Lambda, we're writing a different IP inside the cookie. And so then after the redirect back to the client, it always went through the authentication loop over and over and over again. Yeah, this is what we looked inside. I always thought this would be where the IP addresses of the client, I don't know, that's what I thought. But that's not the case. Luckily, we have CloudFront as the CDN in front of all AWS accounts. And there we found a header that's called CloudFront Viewer Addresses that was stable across all AWS accounts. So we started using that and deployed, and we saw that the errors dropped. This was great. There it also dropped. And we knew this was the problem. Mission complete. What did we observe while doing that? We learned so many things. So normally, this is how we think the internet works, right? A client connects to the internet, and through that maze, it goes to your site, and then the request comes back. But reality is more complicated, especially if you deal with corporate networks. There are proxies in between that do strange stuff, especially in the realm of IP authentication. And so if you look at this, it looks like the Statista homepage, right? But have a look at the URL. That's really, really strange. And now think about how can this happen? It's proxies that are rewriting the URLs to everything. Think about what that does to the cookies. They are rewriting the cookies where they're valid for. And this is something we didn't expect, and I think it's something that you will hopefully not have to deal with a lot of times. But yeah, so a lot of our customers were accessing our site through some proxies. And the proxies then, has the fixed IP address. So that was one thing that we learned. And then also these proxies they just strip away cookies. So this is the cookies that you get through one of these proxies, and this is the normal amount of cookies that we set. It's clicker doesn't go back. So so you see already, if you kind of rely on functionality that's tied to cookies, proxies are not your friend. What else did we observe? Yeah, transparent gateways that tamper with headers. They exchange header information in there, like the IP addresses that they say it comes from, but it comes from somewhere else. Yeah, this is our CRM. This also happened round about the same time. Someone decided to enter a /6 into the CRM. That's 1.5% of all available IPv4 addresses. We only realized that because we just found out that everyone is always logged into one account when we went to the site. And that didn't make sense. It was one thing that we fixed afterwards, that you cannot enter these large IP ranges any longer. They just don't make sense. Also a little bit more serious, so these mob programming and mob releasing sessions were really, really important for the team. The way it worked was someone would just start sharing their screen and go up to a certain point where they didn't know any further, and then someone else would take over the screen, and we would basically for days on end sit in these joint calls all day long. Sounds exhausting, but it was really fun at the same time, because it made the failure more enjoyable in a way, because you were failing together. Another thing, what is a really good idea, is to decouple deployment from release through feature switches, because then you don't have to wait for 20 minutes for a new deployment and then it goes live immediately. That's not a good idea. So what's the aftermath? The future of IP login. It still exists today, but after this ordeal, we realized, this is not something that we can or that we want to support longer. So we asked our dear customer support colleagues to reach out to all clients, around 2,000, and tell them we don't support IP login beyond the end of 2025. This is an ongoing process, I would say. The customers are not very happy, because it has always worked this way, and of course it also works with everyone else. And why do we switch away from it now? And we get these fun requests now, where customers want to know. So they're in Japan. If we switch off IP access by the end of the year, do we mean CET? I don't know if we answered to that. It was just on Tuesday, this request, but I thought it was very interesting. I don't know. We will probably not switch it off by the end of the year, because the most important customers always, they can't switch yet. But if we look at a graph of how many IP logins we have, I think it's going somewhere, right? I don't think it has the trajectory that I would like it to have yet, but it's going down slowly. Yeah. Thank you. I'm open to question.